In the Connecting to MongoDB lesson, you saw that you interact with a MongoDB Node.js driver using callbacks. These callbacks hint at JavaScript's concurrency model, which is very different from other programming languages like Java or C++. JavaScript is a language built to run in an event loop. It's called an event loop because JavaScript interpreters run in a loop that looks something like this. So while, wait for event, process event. This loop has numerous interesting semantics. First of all, the loop is single-threaded, so only one event handler can run at any given time. Second, this loop provides an effective way to break up long-running operations like network I/O. You can simply add an event handler that waits for completed network I/O. Once the network I/O completes, it gets added to the queue of events to be processed. Therefore, instead of thinking of JavaScript as an imperative programming language like Java or C++, it helps to think of JavaScript as running in a loop that executes event handlers that can register other event handlers. At a high level, this is how the Mongo client.connect function you saw in the Connecting to MongoDB lesson works. Instead of blocking the event loop while it connects, the Mongo client.connect function registers an event handler that tells Node.js to execute your callback function once the network I/O that connects to the MongoD server is done. To see the event loop in action, you should ask yourself, what would the following program print out? If you said not in timeout will print before in timeout, you're right. This is because set timeout registers an event handler which gets called on the next iteration of the event loop, whereas the not in timeout statement gets printed in the current iteration of the event loop. Typically, code that executes in the current iteration of the event loop and thus blocks the event loop, like this first log statement, is known as synchronous code, whereas code that registers an event handler and thus doesn't block the event loop is known as asynchronous code. In Node.js, file I/O and network I/O are typically asynchronous. In particular, you will notice that every MongoDB operation that you'll use in this course uses callbacks and is thus asynchronous. This enables Node.js to be highly concurrent by default. You don't have to worry about setting up multiple threads to make sure you're not blocking the CPU waiting on a database operation. Many Node.js developers find callbacks to be cumbersome. There are numerous NPM packages that provide syntactic sugar on top of callbacks, such as async and the various promises libraries. However, callbacks are handy for determining if your code is doing too much I/O. If you have 12 levels of nested callbacks, the problem is probably not the callbacks, but that you have a very complex function that's very difficult to test.